Another thing we can refactor in this code is this long, ugly Boolean expression. I really don't like these three logical ORs. That's ugly. So what should we do? Well, we can put these left brackets inside an array list and then check to see if our list contains the current character. If we have this character in our array list, that means this character is a left bracket. So let's declare an array list of characters. We call it left brackets. Now here's the problem. We cannot initialize this array list like this. So we cannot pass a list of left brackets to the constructor of array list. But don't worry, we have a workaround. In Java, we have this class arrays that is declared in java.util package. This class has a very useful helper method, as list. Look at the type of this parameter. It's t ... That means we can pass a varying number of arguments to this method. So we call this method and pass the list of our left brackets like this. This will create and initialize our array list in one go. Now we can store the result over here, left brackets. Then we remove this long expression and return left brackets dot contains the current character. This is the elegant way of writing this logic. Code like this is very amateurish and it's not scalable. Now, there is a tiny problem here. With this implementation, every time we call this method, we're going to end up with a new array list in memory. So we shouldn't create and initialize this array inside this method. We should declare it as a private field, initialize it once, and then reuse it multiple times. That is very easy. So we put the caret and the variable name. On the top, we go to the refactor menu, then go to extract field. So we want to extract a private field from this variable. Now over here, you can see a preview of this field. So it's going to be a private field of type list of characters called left brackets. Now, look at this initialize in drop-down list. By default, this is set to current method. We don't want to initialize this here. We want to initialize it upon declaration. So let's select this, then press enter, done. In this method now we have only a single line of code. Now we have a private final list of characters called left brackets. And this is initialized over here, only once. The reason this is declared as final is to prevent us from accidentally resetting this field, okay? Now we're going to do the same refactoring in this other method. So first we call arrays dot as list. Here we pass all the closing brackets. Then store the result in right brackets. And finally we return right brackets that contains the current character. And finally we're going to promote this to a private field. So refactor extract field. And we make sure that this is initialized upon declaration. We press enter, done. Our code is getting better in every step. Now, what about this logic? Well, we can declare two array lists, one that contains our left brackets and the other that contains our right brackets, like this. Next, we find the index of the left character in our first array. Let's say the index is 0, so it's over here. Now we look up the item at the same index in our second array. If they match, that means our brackets match. Here's the good news. We already have these arrays. We declared them a minute ago. Let's just make sure that the order of these brackets match. So here's our left array, and here's our right array. As you can see, the orders match. Beautiful. So we can refactor this other method. We go to our left brackets array and find the index of this left character. Then we compare this with the index of the right character in our right brackets array. If the indexes are equal, that means these brackets match. So we type right brackets dot index of right. We have a Boolean expression. Finally, we return this. So this is how we can replace this super long Boolean expression with a beautiful one-liner like this. Delete. We're almost done. Just the last touch. Back to our isBalance method. Let's review this story one more time. We iterate over our input character array. If we get a left bracket, we push it on the stack. If we get a right bracket, first we check to see if our stack is empty. I would like to add a line break here. I want to separate this error handling from these two lines because these two lines are highly related. We pop an item from the stack and then check to see if our brackets match. Now, here is the final result. We're done with this exercise. Next, we're going to implement a stack from scratch.